Hello students, how are you? In the previous class we have started to discuss on the set of complex numbers. We have seen what is the definition of complex numbers, real part, imaginary part, how to apply operations on complex numbers. Today we are trying to see that about additive and multiplicative inverse of a complex number, modulus of a given complex number, how to solve equations in the set of complex numbers, to write the simplest form of an expression in this involving complex numbers, how to find or determine the modulus and argument of a complex number. To start this discussion, first we have to define what does it mean, the absolute value or modulus of a complex number. If z is equal to x plus yi, it is a complex number, then the modulus of z denoted by this one is defined by the square root of x squared plus y squared, which is the square root of the sum of the square of the real part and the imaginary part it will be. If z is equal to x plus yi be a non-zero complex number, then the modulus of the complex number, if it was represented by r, which is absolute value of z, the square root of x squared plus y squared, and theta be an angle made in the vector corresponding to z with positive x-axis, then z is equal to r times cos theta plus I sin theta is called the polar representation of a complex number. And in this representation, r we call is that the modulus of the complex number, theta we call is that the argument of a given complex number. Let z is equal to x plus y be a non-zero complex number. If r it is the modulus of z, which is the square root of x squared plus y squared, and theta b is the angle made by the vector corresponding to z with the positive x-axis, then the complex number z could be written as r multiplied by cos theta plus I times sin theta. This way of writing a complex number we call is that polar form of a complex number. R is the modulus or the magnitude, theta it is the angle between the positive real axis and the given angle it will be in. Here theta, it can be discussed in different forms. When the values of theta is between negative pi out to pi, that means in one complete rotation, we call that one to be principal argument of a given complex number. If z has argument theta to be equal to 30 degrees, we call it as 30, it is a principal argument. If it is negative 90 degrees, it is a principal argument. When you are coming to say that theta is equal to 450, it is an argument, but not principal argument for that one. The other one, we have a complex number. If it was expressed in polar form, say z1 r1 into cos theta 1 plus I sin theta 2, you have theta 1, z2 to be equal to r2 cos theta 2 plus I times sin theta 2. Then the following holds true. What is the product of the two? z1 times z2 in polar form. When you are applying distributive property and using trigonometric laws, r1 times r2 multiplied by cosine of theta 1 plus theta 2 plus I times sin theta 1 plus theta 2. The modulus of the product, it is the product of the modulus of the separate complex numbers. And the argument, theta 1 plus theta 2, it is the sum of the arguments of the separate complex numbers. When you are dividing z1 by z2, you will get the ratio r1 over r2. r1 over r2, it is the ratio of the modulus of the two complex numbers, multiplied by cosine of theta 1 minus theta 2. the modulus of the numerator, theta 1, minus the modulus of the denominator, theta 2, plus I times sine of theta 1 minus theta 2. You may discuss about powers also. Z1 the power of n. R1 the power of n multiplied by cosine of n times theta 1. The argument of Z1 must be multiplied by n, which is the exponent of the power. N times theta 1 plus I times sine of n times theta 1. So these three properties are important. The product of two complex numbers in polar form, it is a complex number having modulus, the product of the separate modulus of the complex numbers, and the argument, it is the sum of the arguments of the two complex numbers. When you are discussing about ratio, the ratios of the two, it gives a modulus, and the difference between the two arguments, it gives the argument of the quotient. For the power, the modulus will be R1 the power of n multiplied by cosine of theta, n times theta 1 plus I times sine of n theta 1. So R1 the power of n, it gives the modulus of the complex number Z1 the power of n. What is the argument? N times the argument of the first complex number, it will be. Then let us see some exercise with this one. Find Z inverse and the opposite of Z in the form of x plus y if it says. So what is that? Z inverse means reciprocal. The minus Z, it is opposite. So what is that? If Z is a complex number which was represented by a plus bi, then what will be its opposite? The opposite of Z, it is the opposite of a plus bi, it will be, which gives a result to be equal to the opposite of a minus bi, it comes. If Z is equal to a plus bi, then we'll have a result. Z inverse will be equal to 1 over Z, which gives a result to be 1 over a plus bi. This is the reciprocal of the given complex number. But the problem is that what is the real part and the imaginary part of this complex number? To find that one, you will have a result. You have to multiply this one by the conjugate of the denominator. 1 over a plus bi multiplied by a minus bi over a minus bi. This is the reciprocal of that complex number. But the problem, it doesn't show that what is the real part and the imaginary part. To get that one, you should be able to multiply both numerator and denominator by the conjugate of the denominator. So when I multiply it, I will have a minus bi over a plus bi times a minus bi. Since they are conjugate of each other, the product will be a real number, a squared plus b squared, it comes. So what is the multiplicative inverse of a plus bi? You can give 1 over a plus bi. When you are multiplying by the conjugate of the denominator, both the numerator and the denominator, you will have a result which says that a minus bi over a squared plus b squared. So using this formula, we can try to do some exercise over here. If Z is equal to 3 plus 4i, what is the multiplicative inverse? What is the opposite of Z? If Z is equal to 12 minus 5i, what is the multiplicative inverse and the additive inverse or the opposite of Z? If Z is equal to 3 plus 4i, then what is the additive inverse? How? The opposite of 3 plus 4i. When I multiply it, I will have negative 3 minus 4i. Second, what is the reciprocal of Z? Z inverse. 1 over Z, which is equal to 1 over 3 plus 4i. And what is the real part and the imaginary part? To get that one, you have to multiply both the numerator and the denominator by the conjugate of the denominator. When I multiply it, I will have a result. 3 minus 4i, 3 plus 4i times 3 minus 4i. Since they are conjugate of each other, 3 squared 9, 4 times 4 squared to be equal to 16. So we will have a result to be equal to 3 minus 4i over 25, it is the multiplicative inverse of that complex number. If you split, you will have 3 over 25 is the real part, the imaginary part to be negative 4 over 25. When you come to b, z is equal to 12 minus 5i. What is the opposite? The opposite, it is negative of 12 minus 5i. Applying distributive property, you will have a result, what it says for that. When you come to number 2, find the absolute or modulus of a complex number z. If z is equal to 5 plus 12i, what is the modulus? Z is equal to negative 2 minus I. So to find the modulus, z, it gives a result. If z is equal to 5 plus 12i, in the previous we have discussed, the absolute value of z, it is the square root of x squared plus y squared. The real part 5, the imaginary part 12 squared. Then when I added up, 25 plus 144, which gives a number to be the square root of 169 is equal to 13. What does it mean? This could be thought as a point. If you are taking that 5, 12. We can represent this one graphically. You have the real axis on the horizontal axis, the imaginary axis vertical. 5, 12, you will have a point somewhere here, values of x 5, y to be 12. So this was a point. This is the origin. If I join these 2 points, I will get a vector, which is a position vector, because it starts from the origin and has in the point 5, 12. What is the modulus of z when you say? The modulus of z, it is the square root of, since the origin has coordinate 0, 0, what you call is that? 5 minus 0 the whole squared plus 12 minus 0 the whole squared it will be, which gives a value to be the square root of the number 5 squared plus 12 squared it will give. What was 5? It is the values of x here, the real part. What is 12? It is the imaginary part of that complex number. When you are taking that for b, z is equal to negative 2 minus I. What is the modulus of this complex number? The modulus of z, it is the square root of, the real part is negative 2 squared plus the imaginary part negative 1 the whole squared. So you will get a result 4 plus 1, 5, root 5 it is the magnitude of that complex number it will be. So when he says that magnitude, it is the length of the position vector, which is starts from the origin up to the end point of that complex number as a vector it will be. The other, how do you find the solution set of complex, quadratic equations? X squared plus 2x plus 5 is equal to 0. It is quadratic. How do you find the solution? You remember that quadratic formula. The values of x is equal to minus b plus minus the square root of b squared minus 4ac divided by 2 times a. It was quadratic formula what we have learned before. If I want to use this formula, my a will be equal to have the coefficient of x squared 1, the values of b, the coefficient of x to be 2, c to be equal to 5. I know these 3 values. Then when I substitute here, you will get a result. What is that result? Let's see that one. If you come to the first one, x squared plus 2x plus 5 is equal to 0, right? Quadratic formula. Then when I substitute properly, negative 2 plus minus the square root of b squared, 2 squared minus 4 times a, 1 times c5 divided by 2 times 1. 2 squared 4, 4 times 1 times 5, 20. So under radical, you have a number, negative 16. When you are learning about real numbers, we say this quadratic equation has no solution because it was imaginary number. But in the set of complex number, the square root of negative 16 can be simplified. How? You can write this one to be equal to, you have a value for 16 times negative 1. When this one is simplified, the square root of 16 is 4 times root negative 1. But root negative 1, we have defined I is an imaginary number which was represented by the square root of negative 1. So 4 times I over 2 it will be negative 2 plus 4i plus minus 4i over 2. When this one is simplified, negative 2 divided by negative 2, 1. 4 divided by 2 to be positive 2. We have a solution for this equation. What is the solution for that equation? It will be, you have true set, negative 1 plus 2i, it is 1. Solution for that one, we can write as negative 1 plus 2 times I. It is a complex number. Second one, negative 1 minus 2 times I. It is the second solution for this quadratic equation. Take for the other one also. B, 3x squared minus 2x plus 1 is equal to 0. Still, this is quadratic equation, but the values of A is 3, B negative 2, C to be equal to 1. What is the solution? Again, I will use quadratic formula. And you will have minus B, it is minus negative 2, plus minus the square root of B squared, negative 2 squared, minus 4 times A, 3 times C to be equal to 1, divided by 2 times A. So when I simplify it, you will have positive 2 plus minus 4 minus 12. But 4 minus 12, it gives negative 8. So you have 2 plus minus the square root of negative 8 over 6. What is the simplest form of this complex number? To simplify that one, you have to go further. Root negative 8 means the square root of 8 times negative 1. The square root of 8, it is root 2 times root negative 1. But root negative 1 will be represented by an imaginary number, I it comes. So 2 plus minus 2 root 2 times I over 6. Remember, I is outside the square root. Then when this one is simplified, 2 divided by 6, you have a common factor, 1 plus minus 1 root 2 I over 3 it comes. When I split, you will get a result, 1 over 3 plus minus root 2 over 3 times I. So it has two different solutions. The solutions are numbers which are complex numbers it will be in. Third one, a little bit different. X cubed is equal to negative 1. What is the solution for this one? In the set of real number, I hope x cubed will be equal to negative 1 when x is equal to negative 1. But this is the only solution. Let us see. X cubed is equal to negative 1 means x squared plus 1 is equal to 0. X cubed plus 1, it is cubic equation. It can be factorized. How do you factorize? If you remember, x cubed plus 1 cubed can be factorized. It is the sum of two cubes. The one of the factor x plus 1 is one factor. Second one, it is quadratic, which is equal to x squared minus the product of the bases. You have x times 1x plus 1. You have to remember factorization of the sum of two cubes. Or else, the other one, x cubed plus 1 will be equal to 0 at x equal to negative 1. And when you discuss about polynomial, if f of c is equal to 0, if f is a polynomial and c makes the function to be equal to 0, then x minus e is a factor of that polynomial. Using that rule also, x cubed plus 1 will be equal to 0 when x is equal to negative 1. So negative 1 is one root. What is one of the factor? X minus negative 1, which is x plus 1. The other, by using long division method, you will get this result. Then go further. X plus 1 times this one is equal to 0 means either the first one or the second one is equal to 0 it will be. No? Then x plus 1 is equal to 0 means x is equal to negative 1. But you have got here quadratic equation. So find the solution for this one using quadratic formula. When I use a is equal to 1, b negative 1, c is equal to 1. When I use that quadratic formula, you will have the following result as that given expression it will be. You have x is equal to 1 plus, the plus minus the square root of 1 minus 4 over 2 times 1 to be equal to 2. 1 minus 4, it is negative 3. The square root of negative 3, it is not a real number, but it is complex. When that one is simplified, root negative 3, when it was simplified, you will have root 3 times I it will be. So you can continue for the other one. Root negative 3 means root 3 times root negative 1. So you have to write your solution to be 1 over 2 plus minus the square root of 3 over 2 I. So this equation has 3 different solutions. What? The true set of this cubic equation, it will be 1, the integral solution, -1. The complex solution, 1 over 2 minus root 3 over 2i. It is a complex number. The third solution, we have 1 over 2 plus root 3 over 2i it comes. So, if you remember in grade 10, a polynomial of degree n has at most n solutions. So, since it is degree 3, it will have maximum 3 solutions it will be. One is an real number, the other two are an element of complex numbers it will be. For number 4, simplify the following and write each in the form of a plus bi, where a and b are real numbers. That means you are expected to write the simplest form of these numbers in polynomial form. So 1 minus I is the power of 10. What is that? Multiply 1 minus I 10 times. But to simplify it, C is the first one. A, 1 minus I is the power of 10. By using laws of exponent, 1 minus I squared, the whole raised to 5 it will be. 1 minus I is the whole squared. By expanding, 1 minus 2I minus 1 it comes, because 1 minus I, the whole squared means 1 minus 2 times I plus I squared it will be. But what was I squared? I squared it was equal to -1. So these two will be cancelled. We will have a result to be -2i the power of 5. What is the simplest form for this one? This is equal to -2 the power of 5 multiplied by I the power of 5 it will be. -2 the power of 5 it is -32. When you are coming to I the power of 5, which means I the power of 4 multiplied by I. And what is said? I the power of 4 it is +1 multiplied by a number I. 1 times I, it gives a result to be equal to, you have -32 times I. The simplest form of I the power of 5 it was equal to I. So when 1 minus I the power of 10 is simplified, you will have -32i, which is pure imaginary number. This number has a real part 0 and imaginary part to be -32 it will be. What about for b? 4 minus 2i over 1 minus I. This is the ratios of two complex numbers. So to give our answer in the form of a plus bi in polynomial form, multiply both numerator and the denominator by the conjugate of the denominator 1 minus I. The conjugate to be 1 plus I over 1 plus I. Then we have learned about multiplication. 4 minus 2i times 1 plus I, it gives a product. 4 times 1, 4. 4 times I, -2i times 1, -2i. -2i times I, it gives -2i squared. But since I squared is -1, we'll have plus 2. 1 minus I times 1 plus I, they are a conjugate of each other. So we'll have 1 squared plus, we have again -1 squared to be +1. 4 plus 2 to be equal to 6. 4i minus 2i, it was 2i. 1 plus 1 to be equal to 2. When this one is simplified, 6 divided by 2, 3. 2i divided by 2, it gives 1i. So you will have a result to be equal to, you have 3 plus I, it is the simplest form of that given expression. Here what it says, the simplest form of the ratios of the two conjugates. The conjugate of 1 plus 3i over the conjugate of 4 minus I. First, what is the conjugate of the numerator? It is 1 minus 3i. The conjugate of the denominator, 4 plus I. What is the simplest form of this expression? It is similar with exercise B. So multiply both the numerator and the denominator by the conjugate of the denominator. So 1 minus 3i over 4 plus I times 4 minus I over 4 minus I. When I apply distributive property in the numerator, 4 minus I minus 12i minus 3. Since these two are conjugate of each other, 4 plus I times 4 minus I. 4 squared, 16. The imaginary part here, 1. 1 squared, 1. When this one is simplified again, you have 1 minus 13i over 17. When this one is simplified, 1 over 17 minus 13 over 17i it comes. So this is the polynomial form of the given complex number. Your a or the real part is 1 over 17. Your b, the imaginary part, negative 13 over 17 it comes. When you are coming to D, what is the sum of these two? First, simplify this one. Should be added up with other complex number 6 plus 9i. Since this is the ratios of two complex numbers, it is similar with this one. What is the simplest form of that given expression? 2 minus 3i over 3 plus 2i times the conjugate of the denominator. Should be added up with a complex number in polynomial form, 6 plus 9i. When I apply distributive property in the numerator and the denominator, you will have 6 minus 4i minus 9i minus 6 it will be. 2 times 3 is 6, 2 times negative 2i, we have negative 4i. Negative 3i times 3, negative 9i. Negative 3i times negative 2i, it gives 6i squared it will be. But I squared is negative 1. So negative 1 times 6, it gives negative 6. This will be cancelled. Negative 4i minus 9i, it gives negative 13i. 9 plus 4, it was 13. So when you are looking, negative 13i over 13 plus 6 plus 9i it comes. Simplify it, you will go negative I plus 6 plus 9i. When these two are added up, you will get a result 6 plus 8i. So in the set of complex numbers, we can discuss about simplification of complex numbers. The other, express each of the following in polar form. In polar form, z is equal to 1 plus I, z is equal to 3i, z negative 5 plus 5i, z is equal to negative 1 minus root 3i. To write these complex numbers in polar form, first you have to know the quadrant where they are found. 1i, it could be written as a point 1, 1. So this is first quadrant complex number. When you are coming to 3i, this means 0 plus 3 times I. This is could be written as a point 0, 3, which is found along the positive real axis. Negative 5 plus 5i, it could be discussed as a point negative 5, 5. But where do you find this point? The real part x is negative 5. The imaginary part 5 is positive 5. So it is found in the second quadrant. Knowing the position of the complex numbers will give advantage to determine the argument in which quadrant it will be found and what is the degree corresponding to that argument for that complex numbers. When you are coming to this one, negative 1 minus root 3i could be expressed as negative 1, negative root 3. Both x and y, the real part and the imaginary part are negative. This point is the complex number is found in the third quadrant, second quadrant, on the positive real axis, imaginary axis. This one it is found in the first quadrant. Then let us see how is it possible to find the position vector, how to express the given complex number in polar form. Assume that we are given in the form of z is equal to a plus bi. In the previous discussion at the beginning of the class, I said that this complex number could be expressed in the polar form using trigonometric functions. R multiplied by cosine of theta plus I times sine of theta. This was what you call is that polar form of a complex number. How I got this formula, you have seen in the beginning of the class. This could be shown to remind that what is R? The distance from the origin up to that point. Modulus of z, the square root of a squared plus b squared. And a plus bi can be represented as a point a comma b. Then, what is cosine of theta? This theta, it is the angle between the real axis and the given vector OP. Theta. Cos theta adjacent over hypotenuse. A over r, when I cross multiply it, a is equal to r cos theta. What is sine theta? Sine theta, it is opposite over hypotenuse. B over r, when I cross multiply it, b is equal to r sine theta. What is tan theta? Tan theta, it is opposite over adjacent. So b over a, where a is different from 0. So this was a formula what you can derive when you are trying to find a complex number in the polynomial form when it is changed to polar form. So when you are coming to exercise A, A 1 plus I. This is a complex number having ordered pair to be 1, 1. Where do you find this complex number? This complex number, it is found in the first quadrant. Imaginary axis, you have real axis. The point say 1, 1. When I join with origin, I got a vector. If I call this one to be Z, I mean R, what is R? R, it is the magnitude of that complex number. The square root of a squared plus b squared, the square root of 1 squared plus 1 squared. It gives root 2. Then cosine of theta, a over r is equal to 1 over root 2. Cos theta is equal to 1 over root 2 when you say cosine is positive. Cosine will be positive either first quadrant or fourth quadrant. It will be either first quadrant or fourth quadrant. So what is theta? The values of theta will be is equal to, you have 45 degree, or theta to be is equal to negative 45 degree it will be. But since we are discussing about a position vector 1 plus I, what I said 1, 1, it is a point which is found in the first quadrant. We have to choose theta to be equal to an angle in the first quadrant, 45 degrees, or it is coterminal. Negative 45, it is found in the fourth quadrant. So our complex number, it is 1 plus I, which is found in the first quadrant. We don't need at this time. Then what will happen? If I go, you have theta will be equal to 45 degree, which is in radian form, pi over 4. So what is the polar form of this complex number? We said r root 2, which is the magnitude, multiplied by cosine of theta. Theta it is 45 degree, plus I times sine of 45 degree it comes. But 45 degree means pi over 4. You can express it also. Root 2 multiplied by cosine of pi over 4 plus I times sine of pi over 4. So when you are asked to write complex numbers in polar form, find the magnitude, modulus. Second, determine the quadrant where that complex number is found. By using one of the 3 trigonometry functions, you should be able to calculate the values of theta. If you don't know orally, trigonometric tables are important. I think for today we'll stop here. Thank you, students.